This informative video is brought to you by Energy Solutions Center.
The benefits of using combined heat and power, better known as CHP or cogeneration, are many. And using natural gas maximizes the benefits of CHP, particularly in regards to energy costs, environmental friendliness, and overall grid reliability. CHP systems located at or near the facility needing power reduces constraints on transmission and distribution lines, improving power reliability, safety, and security. Looking at the entire energy delivery process from the source of generation to the end-use site, a great deal of energy is wasted just to produce power and distribute it to the end user. Natural gas comes directly from the well to the end user and is delivered to the equipment on site, making natural gas far more efficient at the site of use as an energy choice. The production, transmission, and delivery of electricity to the facility where it is used has an overall efficiency of around 32%, with approximately 68% lost in generation, transmission, and distribution. By comparison, natural gas is approximately 92% efficient, with only about 8% lost in the extraction and delivery process. With energy being such a precious commodity, it's staggering to consider that over 2/3 of the fuel used to generate electricity in the US is lost as heat. CHP greatly reduces this loss by capturing this heat to create thermal energy. CHP dramatically reduces emissions of carbon dioxide and air pollutants like sulfur dioxide, nitrogen oxide, volatile organic compounds, and particulates. CHP is a major player in the production of energy for North America, and it has reduced the negative overall impact of electric generation on the environment. The reasons for this are clear. It takes less fuel burn to produce needed energy, and most CHP systems are fueled with clean-burning natural gas. So therefore, air pollution and greenhouse gas emissions are even further reduced. According to statistics from the U.S. Energy Information Administration, CHP systems powered by natural gas have the lowest carbon emissions when compared to other fuel sources. Additional exhaust emission treatment methods are also available, such as selective catalytic reduction, which can improve the beneficial reduction of total exhaust emissions. Generally, CHP reduces pollution by more fully utilizing the energy in natural gas to produce heat and power, yielding 1/2 to 1/3 of the emissions from separate applications. Investment in a CHP system is a cost-saving strategy with proven results for industrial complexes, commercial businesses, large residential facilities, and institutions. Efficiency is traditionally defined as output energy divided by input energy. The total CHP system efficiency is equal to the total output energy, including the electrical energy generated and the energy recovered from waste heat, divided by the total input energy. Fuel and energy costs are considerably reduced when using CHP. A CHP system gets up to 3 times the useful energy from fuel and can cut fuel costs for users by up to 2/3. The use of natural gas for CHP is optimized when used together for power generation and thermal applications, resulting in reduced energy costs. Spark spread is a common and important term used in the discussion of CHP and is probably the key metric in understanding the economics of a CHP system. It is the ratio of the cost of electricity to the cost of natural gas. To calculate a spark spread, the cost of electricity and the cost of natural gas must be converted into a common unit, such as dollars over MMBTUs. A ratio of 3:1 or better is considered a good spark spread. For example, if the electric cost is 10 cents per kilowatt hour, that converts to $29.30 per million BTUs. If natural gas is $8.50 per million BTUs, the spark spread would be 3.4. A properly designed CHP system can provide essential power reliability and dependable electric and thermal energy on a continuous basis, resulting in daily operating cost savings. The electric grid is subject to outages for a number of reasons, which can result in costly and serious consequences for businesses. The American Council for Energy Efficient Economy says that more hospitals, residential buildings, universities, and public service facilities use CHP today to keep their power, heat, and critical equipment running during events like blackouts, severe storms, and hurricanes. Reliable outage protection is also cost-effective. Backup or emergency standby power systems are very important and commonplace today, but are very costly for any business. However, the incremental cost associated with using a CHP system for standby power is fairly small when compared to the money saved by avoiding the need of a dedicated standby generator. The reliability and positive environmental impact of natural gas usage is already well documented, and the use of natural gas for existing CHP is the preferred fuel choice. This is due to natural gas being widely available and competitively priced when compared to other fuel sources. When exploring the benefits of a CHP system powered by natural gas, the results are not surprising. The end user saves money and reduces the impact on the environment, while improving the reliability and stabilization of the electric grid by reducing peak electric demand. A CHP system can provide reliable and continuous electric and thermal energy to a user, resulting in daily operating cost savings. In this type of configuration, the CHP system would be sized to meet the thermal and electricity baseload needs of the facility. The grid would provide the supplemental power required to serve the facility's peak energy needs on a normal basis, and would provide the entire facility's power when the CHP system is down for maintenance. Combined heat and power systems powered by natural gas are a reliable and dependable solution for electric generation. For more information on CHP systems, please visit www.understandingchp.com.